Okay, so today I will be discussing some physics principles relating to the pop-up boat and its engine. Well, we know that boats are useless pretty much if they can't float, so the first question I will be addressing is about why the boat itself floats. So the main reason why things float is buoyancy and the resulting buoyant force, which is the upwards force that acts on an object, in this case a boat, submerged in a fluid, which in this case is water. So here we have some water and the boat is floating on the surface. So buoyancy occurs when there is a difference in depth because the deeper you are in a fluid, the greater the fluid pressure is. And so mathematically, the buoyant force is equal to the density of the fluid times the volume the object displaces times gravity. If we also look at the equation acceleration equals the sum of the forces over mass, we find that the buoyant force and the force of the earth are actually equal and opposite because the boat's acceleration in the y direction is 0, so the sum of the forces has to be 0. The boat floats because the buoyant force balances the force of the earth. The next question is, how does heat transfer to the boat's engine? Well, here we have a lit candle, and this flame right here contains rapid moving particles that collide with the particles that actually make up the boat's engine. So similarly to the gas properties PhET lab that we did, when you add heat to the system, the container holding the gas transfers the heat when the molecules collide with the container. So in the case of the candle and the boat's engine, the heat is transferred to the metal of the engine, and the air molecules within the engine's air pocket collide with the metal, which then increases their average kinetic energy. To continue further with this concept, the next question is, how is heat converted into mechanical work? So adding heat to the engine from the candle raises the temperature of the container in addition to the particles, both air and water, in the engine's pocket. So when the water in the engine heats up, steam is created, causing the engine to expand, which is positive work done by the gas. Cold water is then sucked into the engine through the straws, which then removes heat from the system, causing the engine to contract, which is negative work done by the gas. And then this cycle repeats because heat is continuously added by the candle and then subsequently removed by the cold water that filters in, causing the engine to expand and contract, and in other words, causes the gas to do both positive and negative work. So mathematically, we can use these three equations to explain the processes that the engine experiences. And as a visual, this graph shows the processes that the pop-up boat engine goes through. So from point 1 to 2, the volume stays constant, so it is an isochore process, but the pressure increases, therefore the temperature must increase because the molecule's average kinetic energy increases. So the average kinetic energy is directly proportional to the change in internal energy, and we can confirm this using PV equals nRT, T being the measure of the average kinetic energy. And so no work is done on this system, so we know that heat must be added because delta U equals Q plus W. From point 2 to 3, the pressure stays constant, but volume increases, so it is an isobaric process. Increasing volume means negative work is done on the system, and internal energy increases because the temperature must increase in order for the molecules to maintain constant pressure at a greater volume. Therefore, we know that heat is being added in this process as well. From point 3 to 4, no work is done because the volume is constant, which means this is also an isochoric process, and internal energy decreases because the temperature decreases when the pressure decreases, so we know that heat is being removed. And finally, from point 4 to 1, the volume is decreased, meaning positive work is being done on the system, but pressure remains constant, making this an isobaric process too. And then internal energy decreases because the temperature must decrease in order to maintain that constant pressure. So again, we can deduce that the heat must be removed. Finally, the last topic is friction on the boat caused by the water. When the boat is moving through the water, it's slowed down by the net drag force, like by the water molecules. So another way to think about it is like a person walking through air, or like hypothetically like honey, and this just kind of shows how each fluid has a different viscosity. So the outward frictional force is different, but it's the same concept with the boat in the water, and it just shows how the water is actually slowing down the boat through friction.